So, Shadow, let's teach you how to make a 555 astable timer. First, we should probably familiarize you with the components. Here's the main thing to the timer. It's a 555 timer IC chip. An integrated circuit is pretty much a bunch of components put into one small package. It makes it very convenient. It'd be really hard to make one of those yourself out of normal components like these. So, if you look at it, you can see that it has 8 pins. It's called an 8-pin dip, but you don't really need to know that. So, how you read the pins is you read it in a U. You go from top left down and around like that. So this first one is pin 1, then pin 2, 3, 4, 5, 6, 7, 8. And if you had a bigger IC chip, like wherever the heck this one is, it's probably a 14 pin. You'd start from the top left again and do pin 1, pin 2, pin 3, pin 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's how you count the pins on an IC chip. If you see there's a little dimple in it, it's hard to see on camera, but it looks kind of like that. That marks the top of it, so you can know where to start counting. Over here we have a resistor. That one's 10k ohm. I know because it came in a package that said 10k ohm on it. And the symbol looks like that. That 10k is the value and it's in ohms. 1k ohm looks the same. Here's an LED. If you notice on the LED, one lead is longer than the other. The longer one is called an anode. Shorter is called a cathode. You don't really need to know that now, but what you do need to know is the longer lead is positive and the shorter is negative. That's an LED. And over here we have a variable resistor. It's just like the resistors over there, only you can tune it or change it. This is pretty much what a volume control knob is. You could turn that. You kind of need a screwdriver or 2 hands, but you can turn that and it'll go. Those are 10k's in value, so they can go from 0 to 10k ohms. Over here we have electrolytic capacitors. They were in order. One of them's 100 microfarads, then 10 microfarads, then 0.1 microfarads. Electrolytic capacitors just means that they're polarized, so the positive side has to go to positive and the negative to negative, which the longer lead thing's the same. The longer lead is positive, shorter is negative. Also, you'll notice there's a white line, which you cannot see on camera either, that has negative on it, and that shows the negative sign. But longer lead, positive, shorter, negative. Over here we have a solderless breadboard. This is pretty convenient because it makes so you don't have to solder in stuff. Instead of putting an IC or something in and then soldering it, all you have to do is push it in there and it connects to stuff how you want it to. How it works is all these rows like that are connected. They're connected vertically, but not to each other. So if I put something in here, it would be connected to that pin right there. If I connected something right here, it would be connected to that bottom pin, which is pin number 4 on the IC chip. Hopefully this makes sense to you. Let's show you the bottom of one. See, you got wires going up and down, and also over here it's all connected like that. You can see, like, in there it's all connected left and right. So if I put something in that red line right there, then something else that would be right there would be connected to it. So if I did this and that, those two things are connected, but if I put it on the negative side, they're not connected anymore. And if I put it on this other one, they're not connected. Those are connected because they're in the same row, but if I move this one over, they're not connected. Alright, now here's a prototyping board. This you actually solder to. They have little copper circles on the bottom. We'll get to that later. And that is pretty much a 555 time array stable circuit. It's a little different. I modified it a little bit, but that's what it should end up looking like it if you solder it and make it permanent. Then we have the 9-volt connector and a 9-volt. So I'll teach you how to make a circuit on the breadboard in the next video.